Good morning, dear children. Today we are going to learn two more congruent rules. First one is SSS congruent rule. Second one is RHS congruent rule. Children, observe these two triangles. SSS congruent rule means side, side, side rule. Okay. In these two triangles, 5 centimeter, 5 centimeter and one more side 7 centimeter, 7 centimeter and third side is 9 centimeter, 9 centimeter. That means all three corresponding sides are equal. Right? So these two triangles are congruent if all three sides of the triangles are equal in length. Okay children, now we are going to see RHS congruent rule. RHS means right, R stands for right angle, H stands for hypotenuse and S stands for side. Okay, here in these two triangles you can observe 90 degree, 90 degree and base 8 millimeter, 8 millimeter and hypotenuse 10 millimeter, 10 millimeter. Okay children, not only base here, if you can consider perpendicular length also. Sometimes perpendicular lengths also will be same. So these two right angle triangles are congruent if the hypotenuse and one matching side are equal in length and 90 degree also. Okay children?
Hi everyone. Today I am going to explain example 7 from exercise 7.3. Okay. This example is very important and very interesting also. Okay children. Let's come on. Now you see AB is a line segment. Okay. P and Q are points on opposite sides of AB. Such that means see here, this is the AB line segment. This is the AB line segment. Okay. We have to take P and Q points are opposite sides of AB line segment. Okay. That means P point you have to take one side and Q you have to take another side. Then such that, but condition is there. See that one. Each of them is equidistant from the points A and B. Okay. Each of them is equidistant from the points A and B. That means P point, suppose I am taking P point this side. Okay. That should be equidistant from the points A and B. That means you see here. I am taking for example P here. Okay. When I am drawing, why I am taking here, you see. This P point should be maintained equidistant from the points A and B. That means distance between length of PA, length of PB should be same. Right? Now we have to take Q point also in the same way. Here I am taking Q point. See. Okay. And this distance and this distance should be same. Okay children. Now this much are the given conditions. What are the given conditions? PA equals to PB and AQ equals to BQ. Since P and Q are the equidistant from the points A and B on opposite sides. Okay children. Now you see, show that what we have to show, PQ is the perpendicular bisector of AB. PQ is the perpendicular bisector of AB. That means I have to join this PQ line. Right? So when I am joining this P and Q lines, this PQ line segment should be perpendicular. That means here it should be formed 90 degree perpendicular bisector. Bisector means, see I am taking here intersecting point O. Okay, bisector means this length of AO and BO should be same. What we have to show? What do we have to show? Angle POB. 90 degree we have to show. Okay, either this side or this side. Okay, 90 degree we have to show. After that, OA equals to OB also we have to prove. OA equals to OB. Okay children? Now understood? PQ is perpendicular bisector of line segment AB. This one we have to prove. Now you see, one thing we can observe here, what? AB is a line segment. That means straight line, right? So this one forms 180 degree here at the point of O, right? This is the condition. Straight line forms 180 degree at any point. So here 180 degree. Okay. So what we have to prove? We have to prove POB 90 degree. Angle POA also 90 degree. Here 90 degree and here also 90 degree. That means these two angles should be same, right? And these two sides also should be same. This one we are going to prove. Okay. For that one, what you will show here, you see triangle PAO. You observe only this triangle PAOB. This triangle and PBO, this triangle. Okay children? These two triangles, if I will show these two triangles are congruent, then these two angles will be corresponding angles, will be same, and these two sides also corresponding sides, and these two also will be same. In one condition only we can prove these 2 points, right? So we have to show, first of all, this is congruent to this one. But sufficient conditions are there. What we have? Only one condition is there. Minimum we should have 2 conditions. From the 2 conditions we can bring another condition. Okay. But still also you see this PAPB same. PO is the common. Can you get there another 3rd condition? You try. Okay. Direct we will not get. Already we have to show these 2. Remaining what? These 2 angles and these 2 angles. But this is not perpendicular bisector of the angle P. Not given. Okay, these 2 angles also not equal. We don't have the 2 conditions also. Then how you will prove this triangle is congruent to this triangle? Okay, if you have these 2 angles are equal, then you can tell side angle, this is the side. SAS congruent rule, by SAS congruent rule, you can tell these 2 triangles are congruent. After that you can tell this is the these 2 angles equal 180 degree. It should be 90-90. Then these 2 sides also will be equal. Like that you can tell. But how? How these 2 angles will be equal? Otherwise these 2 angles will be equal. You see now. Now you observe. Before that I am going to prove these 2 triangles. What triangles? PAB. Triangle PAB and triangle PBQ. Sorry, PAQ triangle, PBQ triangle. I will show these 2 triangles are congruent to each other. Okay. So, you see here in triangle, which triangles? You observe in triangle PAQ and triangle PBQ. Okay children, in these 2 triangles, you see the conditions. Now I am going to prove these 2 triangles are congruent. Then these 2 angles will be corresponding angles, then that will be equal. Okay, for that I am showing this whole triangle and this whole triangle will be congruent. Okay, purpose is this one. Now you see here, these 2 corresponding sides PA and PB, right, equal, and AQ, BQ also equal, AQ, BQ also equal, corresponding sides, right, you can check here, and PQ also common. Okay, PQ is common. So by which congruent rule these 2 triangles will be congruent? By SSS. 3 sides of the 2 triangles are equal, right? So by SS congruent rule, you can tell this triangle is congruent to this triangle. Okay, that only we are going to write. PA equals to PB. Sorry children. PA equals to PB given. Okay, and what given? AQ equals to BQ given. Right? PQ is common. So therefore triangle PAQ is congruent to triangle PBQ. By which rule? SS congruent rule. By SS congruent rule. Okay children, now you see, I am going to rub this whole thing. Now triangle PAQ, triangle PBQ. These two triangles are congruent to each other. Right? So in these two triangles, what is the common angle? P. Here P and here also P. That means this angle and this angle same. Right? Already given PA equals to PB, AQ equals to BQ given. Right? Now we can tell triangle PAO. Okay children? Triangle PAO, then triangle PBO. Okay? We will write here in triangle PAO and triangle PBO. What are the common? PA equals to PB. PA equals to PB. Yes, corresponding sides. Okay. Then what is the common PO? Right? This PO and this PO is common. PO is common. Then when these two triangles are equal, this angle is equal by CPCT. Right? So that means angle APO equals to angle BPO. So yes, okay, yes, side, angle, then side. So by SAS congruent rule, okay, these two triangles are congruent to each other. Right? By SAS rule. Okay children? So when the SAS rule, these two are congruent, this angle also will be equal by CPCT. Because what is this angle? O, POA, angle POB. That means this O, last angle. Corresponding. Okay. That means, so angle POA equals to angle POB by CPCT. Right? This total angle how much? 180 degree. And these two angles are equal means each angle will be equals to 90 degree only. Right? So angle POA is 90 degree. Perpendicular we got. Now what we have to prove? Perpendicular bisector of the line segment AB. Bisector means this OA should be equals to OB. Of course, now you see this AO and BO. Corresponding sides. By CPCT, these two also will be equal. Okay. So OA equals to OB by CPCT. Okay children. Now you can tell, therefore, PQ is the perpendicularly bisector of AB line segment. Okay children. See, in one point only, by seeing these small two triangles are congruent, you can tell this one is 90 degree and these two are equal. But in first attempt only we cannot prove these two triangles are congruent to each other. So we have taken this whole triangles. Then these two angles will be equal. So then from these two small triangles we can apply SAS rule. After that only we can apply. Okay children, thank you all.